Let's talk about how to classify real numbers. When we talk about classifying real numbers, we are really talking about a few different categories that we put real numbers in. So real numbers represents the group that pretty much every number we deal with in basic math falls into. Now, when I say basic math, I mean anything lower than, say, algebra 2. Real numbers are all of the numbers we deal with below about algebra 2. If you're asking yourself a question, is there such a thing as a non-real number? The answer is yes, there is a non-real number. We don't really deal with them too much other than to say they're non-real. And a non-real number happens when you take a square root of a negative. So for example, the square root of -4 is an example of a non-real number. And at this point, all we do is just say that's not a real number. Real numbers are what we spend most of our time doing in math class or dealing with in math class. And real numbers fall into a few different categories. So the main division in real numbers is between rational numbers, which are numbers that can be written as fractions, and irrational numbers, which are numbers that cannot be written as fractions. So that's the main division. A real number is either a rational or an irrational. Now, if it is a rational number, we can further classify it as a number that is just a rational or a number that is both a rational and an integer. An integer is a rational number that is not a decimal and does not have a fractional part to it. So some examples are -1, -2, -3. They do not have a decimal or fractional part to it. They can still be written as fractions because they are still rational numbers. For example, -3 we could write as a fraction by doing -3 over 1. -3 over 1 is a fraction version of -3. So they can still be written as fractions. They just don't have fractional parts. For example, -3 and 1/3 is not an integer because it has a fractional part. Okay, and if something is an integer, we could further classify it as a whole number. So a whole number is an integer except it's positive, a positive integer. So a whole number has no fractional part, no decimal part, and it must be positive. So 0, 1, 3. Now, if you're looking at the square root of 4 here and thinking, hold on, that's not a whole number, that's got a square root in it. Well, what is the square root of 4? The square root of 4 is 2, and 2 is a whole number. So the square root of 4 would be classified as a whole number. So let's take a look at these three examples that we have: the square root of 5, -17.84, and square root 81 over 9, and see if we can classify these in their different categories. And let's start off with the square root of 5. Now, the reason I have my calculator pulled up here is so we can actually put in the square root of 5 into our calculator and see what the value is. And the square root of 5 is 2.23606797775, and the reason that the decimal stops right there at 775 is not because that is the end of the decimal, but rather because my calculator will not show any more digits. So this is a decimal that would continue on, and it does not have a pattern to it. There's definitely no repeating sequence of numbers here. So we would classify the square root of 5 as an irrational number. This cannot be written as a fraction because the decimal is not terminating and it does not have a pattern. It is not a repeating decimal. It's irrational. Now notice that irrational, any number that is irrational, is also a real number. So we could classify the square root of 5 as not only irrational, but also real. So square root of 5 is both an irrational number and a real number. Let's move on to -17.84. So we see the negative and we immediately think integer, because integer is where all of the negative numbers live, right? But integers do not have a decimal part to them. Integers cannot have decimal parts. So -17.84, since it has a decimal, cannot be an integer. It must be either rational or irrational. Rational and irrational numbers are the ones that have decimal parts to them. 17.84 is a terminating decimal. It does -17.84 and then the decimal stops. There are no more digits after the 4. So because this decimal is terminating, it is a rational number. So this is rational. And anytime you have a rational number, like we do here, the rational number is also underneath the category of real numbers. So that means it's rational and real. Hopefully you're figuring out that if a number is rational, irrational, integer, or whole, it is also going to be real. All of these are going to be real numbers. Okay, and then the last thing we have here is the square root of 81 over 9. Now you may know the square root of 81. It's not a difficult square root, but let's go ahead and use the calculator just to make sure. The square root of 81 is 9. So what we have here is the square root of 81, which is 9, divided by 9, or 9/9 as a fraction. And 9/9 reduces to 1, because 9 divided by 9 is 1. And 1 is all the way in that middle section called whole numbers. So 1 is a whole number. If it is a whole number, though, it is also inside that integer circle. So anything that is a whole number is also an integer. And the integer is inside the rational numbers section. So anything that is an integer is also rational. And as we learned on the last number, negative 17.84, anything that is rational is also real. So the square root of 81 over 9 is a whole number and an integer and a rational number and a real number. It is all 4 of those. It fits into all 4 categories.